Hello and welcome back. The interesting conversations continue. Now we have someone who is passionate about artificial intelligence and has a truly fascinating presentation on how noise can make us see the world better. We welcome Loubna Bouarfa, who's the CEO and founder of OKRA Technologies. Loubna is listed as a Forbes 50 top woman in tech, an MIT Innovator under 35, and a SciTech CEO of the year 2019. Hello, Loubna. Welcome to the AI series. Welcome.
Hello, everybody. Thank you so much for having me here. It's an honor to be here. My name is Loubna Bouarfa, and I'm the CEO and founder of OKRA Technologies, an AI company for life sciences based in Cambridge and Leiden. So today, I'm here to show you how noise can help us see the world better. The times we have been living during this pandemic have put a lot of uncertainty in our lives, global lockdowns, social distancing, remote working, and these situations have forced us to see the truth more clearly than before, making us stronger and opening windows into a better world. Believe it or not, COVID has brought us even more closer to artificial machines than we think. The title of my presentation, How Noise Can Make Us See the World Better. And this might sound like a contradiction. However, our human brains have this enormous amount of information flowing through our senses. For instance, right now, while you are listening to my presentation, your brain will only keep about 1% of the data it receives. It will only keep the information that supports your current beliefs and judgments about AI. So the process of filtering out, all this information is unconscious. Our brains are designed to seek confirmation of existing patterns and avoid threats. This is known as confirmation bias. So if you look to this slide, we are stuck in a tunnel vision. And if we evolved and survived as species in this earth, it's because we have that. And in machines, when we work with machine learning, the situation is also similar. However, we consider it a bit negative and an undesirable quality. This tunnel vision is known as overtraining in pattern recognition or overfitting in the field of machine learning. So in tunnel vision, a machine learning model loses the ability to deal correctly with new situations that are slightly different than what it was trained on. And this is the problem that we see for both humans and machines. So we can easily see where the tunnel vision or confirmation bias becomes harmful to humans. We saw the presentation before about what is harmful and so on. But if we look to how this confirmation bias is harmful, the increase in, for example, populism and fake news phenomena is an example. We can convince people of many things that aren't true by providing them with more data that supports their own fears and beliefs. So our brains are optimized to seek confirmation and to have almost kind of a fear of learning, fear of getting outside of our comfort zone. And I love this expression by this Australian comedian, Tim Minchin is one of my favorites. We have the tendency to define ourselves in opposition of stuff, not we don't define ourselves as pro stuff. We always define ourselves as anti stuff. So we should do the opposite. We should define ourselves as I am a pro AI. I'm a pro ethical application of AI. I'm pro liberalism, and I think that is the way we need to approach that to avoid the fear of learning, the fear of embracing the uncertainty. So to move away from this fear of learning and to embrace the uncertainty, it's a process we call regularization in machine learning. In the field of regularization, or in the field of machine learning, there are two schools. There is the school that say, well, regularization is a representation problem, which means that to move away from the tunnel vision, we need to change the input. Going back to our fake news example, it would be the equivalent of analyzing high volume of both fake news and genuine news to be able to distinguish them. Others think it's a problem of interpretation. As a result, we need to take shortcuts and fix our brains and just classify from the source what is fake news and what is genuine news. And so regularization works by adding this realistic noise to data. And then a good example is Groundhog Day is one of my favorite movies. So having the same example over and over again, but slightly different, it's what we call invariance in machine learning, are similar variations of the same observations that can be found in the real life, right? And adding more invariance to a machine learning system allows the algorithm to learn better and reach the plateau performance. So yeah, if you think about the Groundhog Day movie, it's amazing. So the main character has this day repeated and repeated again. So it was Phil Connors who was covering weather for the annual Groundhog Day festival. And unlikely for him, he gets stuck in a time loop. And while in the loop, Phil goes through different change curve phases: confused, angry, desperate, and depressed. But one day he reached a turning point and decided to make the most out of his inevitable situation. So he learned new skills, he made friends, he falls in love, and when he wakes up the next day, he got outside of the time loop. So this turning point of when you realize, okay, I'm not stuck anymore, this is what the process is of regularization. So how can we describe that in a curve way? So this is two curves. One is from machine learning, one is from psychology. So the human change curve in psychology, it's called the Kubler-Ross change curve. It's very similar to the learning curve in machine learning. Comparing the two graphs, we can see how the process of overfitting is equivalent to the tunnel vision stage, the confirmation bias, where the acceptance is comparable to the performance plateau stage. So in order to get outside of our tunnel vision and to start to see the holistic view of the situation, we need to pass through the regularization stage. Only in the acceptance stage, we would be allowing an AI system to be deployed in the real world setting. And we know that it's not going to be harmful and it's going to be generalizable enough. So the repeated observation of Groundhog Day from Phil Connors could be considered similar to the concepts of invariance in machine learning. And the addition of noise to the original first day is equivalent to enlarging our data set with additional observations in the same context, adding a random noise, cropping images, adding white noise to videos, etc., etc. So these all examples. So the picture here, the Lena image, and I know if you've studied pattern recognition machine learning, you're already famous with the picture. I don't want to talk about the full picture, but the picture of Lena is being used as invariance to train in machine learning algorithms. So this particular variations of Lena image has been used. They are perceptually the same for our cognition. We look at it, we know it's Lena image, but of course, from a signal signal processing perspective, it's a lot of noises that's been added and a lot of invariance for Lena image. So if we look to the machine learning today, regularization is mostly performed in the interpretation stage to regulate the classifiers. And this mostly involves the use of simple linear models to avoid overfitting. But I argue here that the best way to regulate AI systems is by adding invariance, is at the representation stage and not later. So I I want to come here to the own experience of the lockdown, and which for me was one of the difficult phases in my life. It's not easy, but if we look to every day when we were in lockdown was repeating itself, but in different variations. We're at home, working, maybe having children at home, but it is a same thing over and over again with different variations. And I believe it's similar concept as for invariance. We are lived experience, and that's why been through an experience which helps us to see why it works. With the COVID lockdown, we have experienced similar experience to fill corners in Groundhog Day. And this pandemic defined invariance of the same scenarios to our life. It creates like several new life plots and tests out resilience and made us realize what works in our lives and what didn't work. So, and that's amazing about it. So it's been a regularization of our AI for our own brains on the representation stage, but not just forcing ourselves to accept or reject, but really look and discover the truth about us. So the ability to learn is key to humans, animals, and also machines recently. And in our roller coaster lives and over-systemized routine, we almost forget that learning is a basic human need that we need to also teach machines to do. And by instructing machines how to learn, by giving examples and different variations, we have to truly understand our own learning processes. And we should leverage this understanding to create more space for learning new concepts and expanding our social circle and thinking beyond our routines. So who would have thought that noise could help us see the world more clearly? It turns out that humans and machines don't learn so differently after all. And the lockdown and COVID have taught us something here. Thank you.
Loubna, thank you so much. If you have questions for Loubna, you'll be able to follow her through to the networking lounge and speaker Q&A room. The team will place the link to that room now in the session chat on Hopin. Please follow her through there, where Loubna's going to have her camera and audio on. You'll be able to type questions in the session chat for Loubna to read out and answer. Thank you so much.
Thank you.
Right now, thank you. Coming up now on our startup showcase place, we have Yakub Zabral, the founder of Zeta Alpha, who'll be talking and revealing how new AI search technology can prevent AI and data science teams from going crazy. Now, I'm delighted to introduce our third session, a presentation looking at how we deal with unstructured data, a problem many companies are grappling with. Debjyoti Paul has developed machine learning algorithms for Bing Ads, Microsoft R&D, and worked as a decision scientist at HSBC Credit Risk team. He is now a data scientist at Amazon, and we are delighted to welcome him. Welcome, Debjyoti. I hope I pronounced your name correctly there.
Yeah. My name is Debjyoti. Yeah, you were perfect in pronouncing. Okay, I'll share my presentation. Is it visible? Is my screen visible? Okay, I think it is visible. Yeah. Okay. So thank you for the introduction. So today I'll be talking about something which is called finding pattern in unstructured data. So there's a typo here, finding in unstructured. So first, I would like to define what's a structured data and what's unstructured data and what's a semi-structured data. So structured data is something which we can keep in our database. So suppose like if you think about SQL databases, these are those which can retrieve by queries. These are very well maintained. You have column names, you have keys to join on. So these are what we call structured data. What we find is that in the world of data and business driven by data, only 5 to 10% of the data that we see is only this kind of structured data. So what's the other kind of data? It's like semi-structured data. So what is semi-structured data? So instead of SQL tables, you can have CSV file or XML file, which are still information or data which are still have a form. You can read a comma separated file very easily and then transfer it to SQL. So transforming semi-structured data to structured data is quite easy. Often we don't do it in the full we don't do it upfront because we might need some more data collection when we need some more pre-processing before putting it as a table into SQL or some structured database. But the interest, like this is another 5 or 10% of like the data. So structured data and semi-structured data is like around 20% of the data. So that makes us, question what is the other form of data, and that's unstructured data. What is unstructured data? There is no structure to it. There is no particular pattern to it. It is not readable through a single or 5-10 lines of code. You might need serious amount of effort in reading, processing this data. But being 80% of the data, it makes it challenging to gather information from it, as well as this is kind of something which we look forward to get more insight. And from unstructured data, we actually move to a semi-structured data, and then we actually move to a structured data. So over time, we move from this unstructured data to the structured data by rigorous practice of different kinds of techniques which I'll be talking about. So satellite images, scientific data like atmospheric data, all these things are unstructured data. So social media data is one of the important example of unstructured data. Then mobile data, website content, like if you look at Facebook, YouTube, all these are unstructured data. So let's look at so it's 80% of it, and unstructured data is everywhere. If you want to add more value to your business, structured data are very sparse to start with, because at the very start, and I will talk about some of the examples that I have encountered in my personal projects, where kind of I have seen that there can be a lot of value addition that can be done from this unstructured data. So basically, once you have defined unstructured data, so I will talk about how to recognize pattern in unstructured data. So there can be two types. There can be many types of unstructured data, but I will be focusing the discussion to two types. One is text and one is images. Video or multimedia being a text image form, we can always talk about a combination of text and images, which is a multimedia form. So text and video consist of a large chunk of this unstructured data, and the whole point is like how we can use this unstructured data to your day-to-day business to add value to your business. So suppose like you are a hotel, or you are a director of a movie, and you have directed a movie or produced a movie, or you are an actor in a movie, or you have some products on the internet. So what is the thing that you look for is the reviews, because the reviews helps you to know how your product is doing, as well as to get feedback on the product. So you want to connect with your customer. So I'll talk about chatbot technologies, which are basically media of connecting to it, and how unstructured data is changing those technologies. So you have to gather, if you want to gather any information. So suppose, like for example, if you want to know about any business today, what we do is go to Google, we type that website, find that website, go to LinkedIn, find that website, or go to some startup site and find the website. We want to find the person, go to Twitter or go to Facebook or Instagram. You'll find enough information about them. So then like text to speech, right? I mean, suppose like I'm talking right now in the video, so there can be technology which can generate transcript based on this, and those are like basically unstructured data, because like it's generating from any video. Then a human conversation via SMS, via WhatsApp, all these things are unstructured data, because human language is so much diverse in that sense. We often tend to use 2-3 languages at a time, which is very difficult for to structureize at the very start. So sentiment analysis, I've worked quite a lot on sentiment analysis as one of my research projects. Aspect-based sentiment analysis. Like suppose like I am a restaurant and I'm talking about like some customers talking about, oh, the food was good, but the AC or the lighting was not good, the ambience was not good. So I as a restaurant owner would be much more interested in finding out what went wrong for the customer, what went right for it. So that's one of the way where we need to parse structure, sentiment analysis. So we have to go to some site where people are posting reviews. We have to parse those reviews and to do sentiment analysis for them, because for those products, so that we can improve our service. Chatbot modules. So I talk about chatbot modules in more details, but right now, how most of the chatbot works is that you give a list of question answers and the chatbot respond to that. But if you want to make the chatbot more interactive, if you want to slowly disengage any human in the loop, if you want to make the chatbot respond to questions that it doesn't know, further the chatbot has to go out and learn to Google. So that I'll define that I am working on a chatbot which actually is learning to Google on itself, but it can go very wrong in different aspects, and I'll talk about that. So that's kind of the chatbot. And again, from the image side, like you might want to do OCR. So when I was traveling, I find it, the Google Translate has a feature of translating from image to, so I was in Europe last year, and I didn't know German, so I had to translate a lot from using Google Translate. As well as when I was in different parts of the world, like I had to use Google Translate because I didn't know the language, and it's an amazing technology in that sense. And memes are a form of communication. So right now there is a challenge which kind of try to classify memes, which is kind of interesting, because we are now trying to go to multimedia data and trying to find out what the content is. Because a lot of information is in that. So security-based technology. So we are working on a security-based technology, which is another of my personal project, which we are trying to find security-based system based on cameras or hidden cameras or kind of security cameras. So to talk about machine learning on unstructured data, first of all, like when you decide to go for unstructured data, you have to have a base problem. So I will define some base problem and walk through some case studies. So if it's a classification problem, you have to define whether you have labels or not. If you don't have labels, then probably you have to question yourself that whether I need labels. For example, if I want to classify my a customer into high return customer, low return customer, then I need a label for those things. Then how to find the right data? So once you define the problem, then you have to go and find the right data. To get the right data, so I'll talk about different use scenarios where how we decide to get the right data. So now from the right data, you have to sit with your business, people who have the idea, who knows how to, So for building a chatbot, you have to sit with the customer agent who actually answers right now and walk through how she does it or how he does it, and then get the chatbot do the same thing. So it's about it has to be defined. And second, then we have to go and find the right data. Unless you find the right data, the machine can't do any magic for you. So once you gather the data, so if it is structured data, if you have CSV, you can just move it to a structured data. If it's not a structured data, which is most of the time, we have to do a lot of steps, and we will define 3 steps. One is analyze, build machine learning model, and evaluate. These are the 3 things which we have to keep in mind. So how do I know that I have the right data? This is very, very important. So for this, you have to sit down with the people who know the business sense. So if I am building a model for a bank loan, a bank, you have to sit with a relationship manager who gives out loans and understand what the relationship manager does. What are the criteria that it looks for? Your data, if you have a chunk of data, you can't just start from anywhere. You have to know the starting point. So relationship manager will look for cues that a customer has a good history or it has good deposit. This kind of very features which you can start straight away as a base feature, and then you can build models by different kinds of other techniques that I will discuss. So text analytics, I'll very shortly talk about text analytics. So to extract a lot of this text from the internet, you need something called Beautiful Soup. So Python has a very good library called Beautiful Soup, which can parse HTML for you. Then you have to do all kinds of text analytics. For image, you have to do a different kind of analytics. So this is a word cloud. So you can do different kinds of LDA, parts of space. You can put word histogram. This kind of analytics you can do, and you can get very good insights from the data. For images, you can do a distribution of different grayscale. You can pass through different kind of wavelet transform. So this is one ImageNet model. So this is a large neural network model is trained on millions of images. And what you can do, you can take whatever image you have, you can pass it through that. You will get a base point. You can get some some feature representation of that, and you can analyze that. So this is another way. So there are basic transform like HOG, this is called a histogram of oriented gradient. So you can get gradients of the images. These are good ways to find whether your data is right, whether it's giving some idea about the problem you're going to solve. Image analytics also consists of all these other exploited in data analytics. You can do LD on images. You can do all kinds of frequency. You can convert images to text, and you can do different kinds of other analytics. So another important point to start with is that maybe you are working on a problem where a lot of people have already spent a lot of resources. For example, there is a model which is called Glove or Word to Wake, which is basically text model trained on large chunk of text like Wikipedia. And what can be done is like you can train your model on that. Those models are already available open source. You can start there. So you can use those models to start with. So for example, when I was building the chatbot, the initial vocabulary of the chatbot. So how does a chatbot know that that a word like man is similar to a boy? So for example, to know that, I have to give some information to the chatbot. So the way I gave it is using a model called Word to Wake, which was trained on Wikipedia data. Or I used a model called Glove, which has 6 billion tokens. So 6 billion tokens is the number of words on which it is being trained on. So it is a huge model. So to cover a lot of the text that you are already using, you can retrain the model for your purpose. So that's called transfer learning. So I talked about ImageNet. That's already image classification model trained on millions of images. What you can start there, and you can build your own image model by borrowing the learning from that model via technical transfer learning. The second problem is, so suppose you are at a problem where, because you have unstructured data, you don't have labels for that. So what you can do, you can take help of your friends or colleagues and label a bit of it, and then use the technical label proposition. It's a very well-known analogy or term in social media, where, for example, as a social media, if I see a post and I like it, it is most probably going to be shown to my friends' page or people who follows me. So that means that if something is similar to something, then probably that is much likely to be of the same class. So if you have a set of already good ground truth on some samples of data, you can always propagate it to other samples. So these are two techniques with which you can generate more labels, and you can enrich your models or enrich your feature. And let's now talk about some case studies, some of my personal projects. So I'm currently building a chatbot for one of my friends, and the problem is like the chatbot has to learn on its own. So there are lots of terms that so they want to call different API and then gather those information and try to classify and try to answer. And further, the chatbot has to first get the human response, human question, and classify, and then find out which API to question, and then come back and answer it. So for that, the chatbot might need to learn new terms. So what we are trying to do is we are trying to find out ways for which chatbot will learn different concepts. Also, there can be problems where so right now there's a human in the loop. So if the chatbot doesn't know, it flags it, and the human tries to make some sample data for the chatbot so that it learns it. So it learns every day. But going forward, it will know how to Google on its own, and also it will try to build its own knowledge base. And also the knowledge base should be readable to a human because of all the explainability problems that we see today. And the second thing is that we have to make sure the chatbot doesn't learn anything abusive from the internet, because the internet is a huge circus going on. So it is very difficult for the chatbot to filter out which is relevant, which is not relevant information. So we have to build that thing as well in the chatbot. And also the chatbot should be able to it is kind of also trying to figure out how the company jargon is different from the actual jargon in the real world data. For example, if a bank, if someone is talking about a bank, then it's not about the a river bank. It's a bank about a bank where you keep your money, right? So those kind of disambiguation it has to go through. So another thing is the face recognition for security, and the thing that we are working on is that how can you train your model to know the person who are near and dear to you or who visits your house, and how can you flag that when somebody unknown, try to sneak in or try to move around, it's very difficult, to know, and it can preempt a lot of, harm that can cause to you, or it can do a lot of those stuff. So we are building this kind of technologies which will protect your home from a lot of security issues, or your offices. But then there is a very interesting project where a client wanted, one of my friends company who were trying to build, who basically works with with different kinds of people, different kinds of clients. So they target different kinds of clients. So they call up the phone and sell their service to different kinds of clients. And now the problem is that there are only 100,000 clients, and you can't engage your person or your marketing people to engage with all of them. So you have to prioritize. So how can it prioritize? So probably what they want is that can a machine look at the website of these companies and figure out for the customer agent or the marketing manager to prioritize which customers to go after that. So they have a return on each of the clients, that which clients are high returning clients, and based on that they are leveling the data. And then based on the website, the problem is that a website can be a huge noisy data set. So people put all sort of stuff in the website. To filter from the stuff, so we are building our own in-house techniques to filter out which are the words which are relevant. So none of the things which available right now in NLP caters to that, because it's very unique need where some words might be very much related to high paying client versus some words which might not be, and it's not very intuitive. So you talk with the expert. We have got the basic. So you get the basic features, and now we are building the chatbot model. We are building the targeting model, and we have kind of build it. So we call it Transfer Learn Plus. We are using the base model as Love model, and we are refining our model, and then we are denoising our feature, and we are incorporating expert insight, and we are building the final prediction model, which will rank the client. Okay.
I'm so sorry to interrupt you there, Jyoti. I'm so sorry to interrupt you.
Sure.
We are sadly running over time at the moment, but we do have a Q&A session. So I'd love for you to be able to wrap up your sort of comments with the rest of our audience. We would love to continue the conversation with you in the Q&A session. Thank you so much. If you've got questions for Jyoti, as I said, please do follow him into the networking lounge and speaker Q&A room. The link is going to be dropped into the chat now by our team. So please do follow him through. Jyoti is going to be able to continue with his camera and audio on. So if you'd like to type your questions through for the session chat, he'll be able to read them out and directly answer to you all. Please do try some one-to-one networking via the networking tab, and also add yourself to our WhatsApp group. Head over to the sessions area, scan the QR barcode or enter the lounge and click on the link to join. Thank you, Jyoti. See you on the other side at the Q&A. We now have our next speaker, Iyad Noor, who's an AGI expert and chief AI researcher at Humans in the Loop, who'll be debating the tricky conundrum of AI versus hybrid AI. Over to you, Iyad.